So our today's question was partition array into k distinct groups. Okay, so this is question from weekly contest 464. Okay, I make this kind of video to make sure to subscribe. Okay, so we are given a array of nums and an integer k. Okay, so we have to partition this array into groups. Okay, more than one or more than one. Okay, so in every group, each group contains exactly k distinct elements. Okay, and each elements in nums must be assigned exactly one, means we can't duplicate the numbers. Okay, so one is going to go in one group, we can't put same values in two groups. Okay, that's not the case. Okay, so let me explain you the question. Okay, so this is the question. So they are saying you have to partition this array into the groups, and in every group there has to be a k distinct elements. Okay, let's forget about the distinct element. So in for now, okay, for okay, so how many groups are there? In every group we have to have three elements. Okay, means 6 divided by 3. Okay, in every group we have to have three elements, means in first group we can put our three elements, in second group we can put our second three elements. Okay, that means how many groups we have? Groups we have n divided by k. Okay, that is 3. Okay, and this is completely fine. Okay, but let's see, what we don't have 6 elements in our array. Okay, we only have 4 elements. Then what? We at least we can store, we have to store 3 elements. Okay, k elements. In first group we can store our 3 elements. Okay, this is fine, and we are not thinking about the distinct element for now, we are going to think later. Okay, let's see. In second group we can put our 2. Okay, but we can't do that. We must have 3 elements. Okay, so that means this is false case. Okay, we can't divide our array into the groups and every group have 3 elements. Okay, that means very simple thing. If our n modulo k, if it is not equal to 0, that means we have to return false, because in every group we have to have 3 elements. Okay, that means like 1 5 3 2. Okay, we can put 3 elements in our first group, but in second group we want 3 elements. Okay, and in this case this is not the option, so that's why we can return false. Okay, the first condition very simple. Okay, now let's see duplicates values. Okay, distinct values. Okay, we can put distinct values, that is very simple. Okay, now let's see distinct values. Okay, for distinct values. Okay, so our first condition was very simple. Okay, this is our first condition. Okay, if n divide by k, if it is not divisible, then we can return false. Okay, because in every group we want k elements. Okay, and how many groups we have? N divided by k groups, right? Now let's see for this question. Okay, and in every now 3 values we can put here. Now second 3 values we can put here, and next 3 values we can put in 3 groups, third group. Okay, very simple, but we want every value to be distinct. Okay, so the answer was we have to calculate the maximum frequency, and the maximum, and why we have to calculate that? Because if the maximum frequency same elements we can put in our group, we can divide in our groups. Okay, we are done. Very simple. Okay, for if all the values are distinct and we can divide them into 3 groups, it is very simple, right? This is valid. But if the values are distinct, we don't have to think about very much. Okay, we just have to think for similar values. Okay, in this case 57 occurs 3 times, the max frequency is 3. Okay, 57 occurs 3 times. Okay, and our groups are 3, so we can, you are observing something. Okay, we can put our first 57 in first group. Okay, we can put our second 57 in second group. Okay, we can put our third 57 in third group. Okay, and these values we can put similarly, these are distinct values. Okay, we don't have to care about that. We are saying, okay, so but what if we don't have 34, we have again 57. Okay, we again 57. Okay, we put 3 values in 3 distinct groups, but for fourth 57 we don't have any fourth group. Okay, we don't have any fourth group. If we put 57 into fourth group, then the numbers are, these values are remaining because all these values are filled in three group. Okay, let's see and why this is the case. Okay, so we have to put 57 in, we just have only three options. Okay, if we put 57 anywhere, okay, if we put 57 here or here or here, it is going to be invalid. Okay, that means the max frequency was in this case 4. Okay, the max frequency was 4, and the max frequency, if it is greater than our groups, this is invalid. And what you, okay, and it is, if it is valid, why when it is valid, when the max frequency is not it is less than 3, because if we have three the same values, we can put in different groups, we can put 57 here, we can put 57 here, and we can put 57 here. Very simple. And you can, then you have one question, what if the second max we can't fit? Okay, let's see, second max is 34. Okay, in worst case second max also be equal to max. Okay, so let's see, we don't have 71, we have 34. Okay, so the second max values is 34. Okay, similar, very simple, we can put first 34 here, second 34 here, and third 34 here. Very simple, guys, this is very simple. So let's see how we can solve this question. 57 we can put here, we can put this 57 here, we can put this 57 here, we can put 34 here, we can put 34 here, we can put 34 here, and these all values are distinct values. Okay, and we can put first 104 here, 10449 here, and 22 here, and all three groups are filled with exact three values and exactly distinct values. Okay, so our second observation was, if our max frequency, that is m, if it is greater than our groups, we have to return false. Okay, simple question. Let's see. Okay, let's code it now. Okay, int n was nums dot length, cth, if we are not able to divide the nums into k groups, then we have to return false. Okay, n modulo k, if it is not equal to 0, means we have a group and we have value also, but that values are not equal to k, that means we have to return false. In this example we are seeing, okay, we can split three values in first group, in second group we only have a three values, but in second group we want three values. Okay, exactly three values, so that's why we have written false. Okay, now we have to calculate our maximum frequency. Okay, f req. Okay, for, so we have to, for that we have to create a hash map. Okay, integer hash map of integer comma integer. Okay, teger. Okay, new hash map. Okay, so we are going to traverse on our array. Okay, equal to 0, I less than n, and I plus plus. Okay, we are traversing on our map. Okay, so we our nums array. Okay, and we are putting our nums of I. Okay, nums of I comma map dot get or fault default nums of I comma 0 plus 1. Okay, what this function do, it puts the value nums of 0, and this, what this function do, if the value is not present, it will put nums of I and 0. Okay, if value present, it gives the how many count, and we have to put, we have to increase by 1. Okay, and we have to update our max frequency, equal to dot max frequency comma map dot get nums of I. Okay, so that's how we are calculating our max frequency. Now we have to simply return our max frequency if it is less than or equal to our groups, and how many groups we have, n divided by k. and if it is, we have to return true, otherwise we have to return false. Okay, let's see if it is going to work or not. It is running. Now let's try to submit it. Yeah, thank you so much for watching. If you like the video, if you understand the question, like and subscribe.